everyone. I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this January 2026 lecture series, we are discussing about biomedical transducers and sensors. And now we are going to discuss about the characteristics of measurement system, static characteristics. First one, here we are going to discuss the real world impact on biomedical measurements as our empathy part. And here we have some clinical examples like blood pressure monitors, temperature sensors, and ECG electrodes. Here, the impact is while talking about blood pressure monitors, the accuracy within plus or minus 3 mmHg required. Here the hysteresis, it affects repeated measurements during cutoff inflation or deflation cycles. And while taking temperature sensors, the resolution of zero point 0.1 degrees Celsius essential for deleting subtle fever patterns. Here the drift compensation it needed for continuous monitoring. Same thing while coming into ECG electrodes, high sensitivity required to detect millivolt signals, electrode skin interface, which affects precision and introduce noise. These are all the real world impact on biomedical measurements. See, in our defined part, the essential static characteristics are defined precisely. Here our first one is accuracy and sensitivity, precision, and resolution. What is accuracy? Accuracy is a closeness of measured value to true value, and sensitivity the output change per unit input change, and precision a repeatability of measurements. The resolution part we have the smallest detectable input changes a resolution. Here in accuracy, here we have a percentage error. It is expressed and critical for diagnostic decisions, and it is affected by calibration quality. While talking about sensitivity, here the slope of calibration curve matters, and high sensitivity, which is equal to better detection, and it may vary across measurement range. And in resolution part, it limits measurement precision, and it is determined by sensor and electronics essential for weak signals. These are all the essential static characteristics: accuracy, sensitivity, precision, resolution. See here, here we have additional critical static parameters, which includes linearity, hysteresis, drift, and dead zone. In linearity, deviation from ideal straight line, calibration is linearity, and drift, the gradual change in output over time with constant input. In hysteresis, maximum difference in output when input approaches from opposite directions. Which is common in mechanical sensors, and which includes uncertainty in measurements. Dead zone, the range of input values producing no measurable output change. Here it produces output but it is not measurable, no measurable. And particularly it is occur in detecting small physiological variations. See, additional we have linearity, drift, hysteresis, and dead zone. Here our activity part, we have hands-on analysis on evaluating transducer performance. First thing is examine data set, and second calculate characteristics and compare performance, and finally group discussion to discuss the trade-offs between cost, accuracy, and other static characteristics in medical device selection. See, in this part, I've included on quiz. Our first question is define accuracy and explain how it differs from precision biomedical measurements and provide clinical example. And second question, a pressure sensor has a sensitivity of 10 millivolt per mmHg. What output voltage change corresponds to a 5 mmHg pressure change? Question 3, why is linearity important in biomedical transducers? What problem arises from non-linear sensor behavior? See, in key takeaways, we have foundation of quality and interconnected parameters and practical implications. And in the summary part, we have accuracy, precision, sensitivity, resolution. In accuracy, we have calibration and error sources. Sensitivity and resolution, we have detection limits and amplification. Remember that linearity range have span and calibration curve, and stability factors includes drift, hysteresis, and repeatability. See, I will include some references for static characteristics, which may help you to understand about static characteristics in measurements. Thank you. Thank you all.